Here with another edition of Ask an Astronomer here on a very warm H.R. MacMillan Space Centre office here on unceded territory of Musqueam, Squamish, and Tsleil-Waututh. Our regular astronomer, Marley, is on vacation. She is at the Calgary Stampede, went back home to Calgary, if you can believe it. Marley will be back with us in 2 weeks with a very special guest on the theme of Pride. Here in Canada, we celebrate Pride in July. So we've got another 2 themed episodes this month. And for this episode, I brought on 2 people that are right there at the intersection of science and drag culture. Out in Toronto, there is this fabulous event that's put on by some friends of mine called Science is a Drag. So I'm excited to learn more about this. So our 2 special guests, Dr. Leo Alcorn, who is an astronomer herself. Thank you so much for joining, Leo.
Well, thank you so much for having me.
And also we have a drag performer that brought some science, Molly Kewl. Molly, thanks so much for joining.
Yes, thank you. This is so fun. I'm excited.
So Molly, why don't you start us off? Tell us a little bit about your story. You are doing drag out there as Molly Kewl, and this event kind of helped you kind of like express yourself in a more scientific way. Tell us a little bit more about that.
Yeah, well, so I was really shy when I was little. So science and music, pop culture were the first 2 things that brought me out of my shell. And I decided to bring the 2 together in my drag persona, hence the name Molly Kewl. And so a friend of mine actually sent me the audition process basically to sign up and audition to be part of Science is a Drag, because it was like it's a show basically made for me and my character, because I'm usually the odd man woman out at shows doing this like science shtick, and so this just was the perfect time, and it was an amazing show. I was so happy I got it.
Wonderful. Well, you're going to do or sort of show us some of the things, the science that you're really involved in. But Leo, how about for yourself? You, of course, are in more of the academic field and have used drag more recently to express yourself. Tell us about how that's happened for you.
Yeah, so drag isn't entirely new for me. I used to actually, when I was a kid, I would dress up as a boy very often. I was a little bit gender nonconforming at the time, very, very tomboy. But time went on. I went to graduate school. I started studying galaxy clusters. I'm currently a postdoc at University of Toronto. I moved up here after getting my PhD at Texas A&M University. So yay, Calgary Stampede, I can relate. Yeah, so that being said, one of my favorite parts of the job of science is talking to people about how wonderful and interesting our universe is. And I like to get a little bit beyond the traditional ways of doing science outreach and maybe get a little bit more weird and silly with it. So when I saw the call for performers for Science is a Drag, I thought, oh, this actually is kind of a good idea. My pandemic project actually was I learned ballet and modern dance.
Okay.
So I had been thinking, ooh, I would love to do something that involves dance. I'm not very good, but I mean, that's okay. And I remember thinking to myself, because I started a project at University of Toronto with Professor Howard Yee, studying something called ram pressure stripping, which I'll be talking to the audience about a little bit later. And I thought, ram pressure stripping, that could be somewhat of a striptease.
Okay.
And then that gave me the idea for my main act. It wasn't like a true striptease, but I stripped off my hydrogen, which was very important, and came up with the character of Elle, the alien witch.
Okay. Well, as you mentioned, you used drag and used this avenue to get silly and weird with your astronomy. And that's, as it turns out, kind of what we do here on Ask an Astronomer. So why don't you start us off, Leo, and tell us a bit more about this ram stripping that you have done in your research.
All right, wonderful. Then I'm going to share my screen just a second.
And while
Wonders
Leo
of technology.
is doing that, if you're out there watching on YouTube land and would like to ask Leo or Molly a question, make sure to put those into the comments, and we will answer all of your questions. In fact, if you are here and just want a burning question under the universe answered, you know what? Put that into the comments too. We'll see if we can answer those questions too. So let's learn about the jellyfish in the sky. Dr. Leo Alcorn.
All right. Yeah, I just wanted to tell everybody about this. This was actually the subject of my drag performance. And I've taken a lot of slides from this from the performance to tell everybody here about it today, although I'm getting a little bit more into the nitty-gritty of the science since I don't have to dance it all out. But one of my great interests now is something called ram pressure stripping, and in late stages of ram pressure stripping, that can cause a very interesting morphology in galaxies that we call jellyfish galaxies. And this only happens in certain environments, and I'll be getting into that. But I'll start out with one of the things I really like most about galaxies is that they're so diverse. They can come in all sorts of weird shapes. Like here's sort of the three main categories. There's elliptical galaxies, which appear sort of spheroidal. There's spiral or disk galaxies. We're in one of those actually. And they can have spiral arms, or they might not have spiral arms. But the main thing is that they're rather flat and look like maybe a CD if you're not one of the youths who have never seen a CD. And then there's sort of a other category of galaxy shapes. That's called the irregular. And these can look like anything. I mean, literally anything. This is one of my favorite pictures of an irregular galaxy because to me it kind of looks like a vomiting hummingbird. But irregular galaxies can look like anything. So these are all examples of irregular galaxies except for the Sombrero galaxy, which is a disk galaxy.
Speaking of the Stampede.
Yeah. So, I mean, galaxies can look like a rose. This is interacting. These are interacting galaxies that look kind of like mice. There's the Sombrero galaxy, another sort of weird looking one. Does actually look like a sombrero. This is called the antennae, but to me, it just looks a little bit like a train wreck. I don't know about you. But these weirder morphologies are usually created either in sort of very early stages of galaxy life cycles, or what I find more interesting, due to interactions with other objects outside of a single galaxy. So you'll actually notice that these three irregular galaxies look like they're going through mergers of some sort. And mergers can do very interesting things to the shapes of galaxies, including jellyfish. So this is the typical jellyfish galaxy. So there's a few important things that I want to point out about this jellyfish galaxy. First of all, it actually does look a little bit like a jellyfish. You can see sort of the head here and the tentacles coming down here. So they're sort of defined by these very long gaseous tendrils that look that sort of give them the name of the jellyfish galaxy. There's also stars and dark matter and sort of the main part of the galaxy. An important thing about jellyfish galaxies is that the gas gets separated from the stars and the dark matter in the galaxy. And because of the gas being pushed off of this type of galaxy, you see trailing star formation, which is caused by the pressure that actually pushes the gas off of that galaxy. And this only happens in dense cluster environments. We don't see jellyfish galaxies in isolated environments. So the Milky Way isn't going to look like this, for example. So galaxy clusters are a little bit of an important part of this story, though, because you require different components of a galaxy cluster in order to have this morphology happen. So this is just sort of a little diagram of how a galaxy cluster works. So the galaxy cluster is made up of somewhere between 10 and 100 galaxies. They can be very, very massive, and they're sort of the largest thing you can categorize in the universe as like a single thing, biggest thing you can call a thing. So there's the member galaxies that you see here. You can also see there's a large central galaxy called a brightest cluster galaxy. And oftentimes these have very, very large black holes in the center. These are some of the largest galaxies that you'll see in the universe. And when these black holes are eating matter at a large enough rate, they actually can shoot jets off of them and create bubbles. And the bubbles are created in something called the intercluster medium, which is super duper hot gas that actually makes up most of the baryonic, that is regular matter, things that aren't dark matter, matter that we actually understand, because we don't understand what dark matter is at all. But it's hot gas, usually made mostly of hydrogen. Most of the universe is made out of hydrogen. And it's so hot that the gas actually glows in X-ray light. And that hot gas is actually a very important part of the story of jellyfish galaxies. So before I get a little bit more into jellyfish galaxies, I briefly need to get into the structure of a galaxy. So here's a picture of our neighbor Andromeda here with some different parts of the galaxy pointed out here. Galaxies, you can tell what different parts of a galaxy are based on the color that you're actually looking at them in a telescope. So if you want to pick out, say, older stellar populations, you look for sort of a yellowish reddish color. So you can see actually where the old stars are in comparison to the baby stars, which have more of a bluish color. And surrounding all of that is this warm star-forming gas. Again, mostly made out of hydrogen. And if you looked at the hydrogen and split it up in a spectrograph or in a prism, you would actually see that it glows red most of the time. We call that hydrogen alpha in the field. So it's this galaxy is sort of cloaked, like me in my drag performance, in this red gas, which is where the stars form. And when two galaxies collide, or when a galaxy collides with something else, the components actually can separate. So here's that train wreck sort of looking galaxy cluster, galaxy again, not a galaxy cluster. And so there's two galaxies here merging, and you can see these older stellar populations and younger stellar populations are in very different locations from where the dark areas of dust are and where the gas is. We don't actually see the gas picked out here, but a merger or interactions with other objects can separate actually the components of a galaxy. And this is actually seen in another example of this is two merging galaxy clusters. And there's different components of the galaxy cluster in different colors here. So due to weak lensing analysis, there's the dark matter is located in the bluish regions. There's stars that appear yellow and white. And then there's gas, which was measured via X-ray light, in pink. In bisexual colors, as I like to joke. And this is one of my favorite galaxy clusters. I even have it tattooed on me, actually. It's called the bullet cluster.
Oh, yes.
Yeah, it's a wonderful cluster, but what happened here is that this galaxy cluster passed through this galaxy cluster. And as it did, you can see a shock wave form in this gas. This is due to ram pressure. So what happens is that the gas of both of these clusters actually collides and hits each other and heats up. And when gas is compressed and hot, it gets very, very hot and it can form stars. Whereas, in comparison, the stars and the dark matter have separated. So this not only tells us about how the actual process of ram pressure works, but it actually tells us that dark matter is distributed in a way that is non-collisional, as we say. So it doesn't act like the gas, it acts more like the stars. Very useful information for solving the dark matter mystery.
Yeah.
And so on a galaxy scale, this can also happen because as a galaxy, say, enters a galaxy cluster, the pressure as it hits that dense intercluster gas will collide with the gas of a galaxy. So this is sort of in the first 100 million years of a galaxy entering a galaxy cluster. And you can see its gas coming off of it to make it look a little bit like a young jellyfish. And as time goes on, more of the gas gets ripped off and forms these beautiful tendrils. And depending upon where we, the viewers, are relative to where this interaction is happening and how long it has been happening, this can look very different. So this is sort of a simulation of this happening, actually. As a galaxy enters a galaxy cluster, you can see little bits of that gas coming off. And forming new stars, creating lovely tendrils. This is just an artist's impression, as the pop-up said as well. So that's how you get these lovely long tendrils of galaxies. And what happens actually is that this shuts off star formation in galaxies, in galaxy clusters. And this actually is one of the explanations for an observation that was noticed sort of early in galaxy cluster history, that galaxies in galaxy clusters look far redder and have older stellar populations than isolated galaxies like our Milky Way. So this is one of the mechanisms in which star formation shuts off at a galaxy-wide level. So just to summarize a little bit, here's our galaxy, our jellyfish galaxy here, and we can go jellyfishing with SpongeBob here. But these galaxies are one of the many weird and interesting physics that can happen as galaxies interact with the intercluster medium, or the super hot gas that makes up a galaxy cluster. So I hope that you all found that interesting. And when I did Science as a Drag, I ended this talk actually by dancing to Depeche Mode's song Stripped, and stripping off my beautiful red robe here to some fans, but I kept my stars on. Thank you.
Wonderful. Thank you so much, Dr. Leo Alcorn. You know, dark matter, I think, is one of those most challenging concepts, even for us here at the Space Center, to talk about with the general public, because we're talking about something that you can't see or interact with, and the tools that we use to observe the universe, the biggest structures in the universe, as you just described, can be challenging. And I find that that art, and even just you finding these simulations, artistic renderings, can really help us understand some of these challenging concepts. As you were developing your piece for Science as a Drag, was there anything that any revelations you had even about your own science as you were trying to think about how to convert this message to this different audience?
I hadn't really realized sort of the time scales that would be needed in order to actually do the stripping, and sort of the densities of gas that would be required. Because when I was working on the actual dance, I was thinking that I should get like a big, powerful, like metal fan or something to blow on me so that I could strip this off with the help of the fan. But we were having trouble finding a big enough fan in time. So instead, what happened is we got all of the organizers together to wave a bunch of fans at me at the same time. And I was also trying as well to figure out how to sort of show the orbital path that this galaxy would be on, because ram pressure stripping happens at during the first pass of the galaxy entering the galaxy cluster, and the galaxy itself is actually moving through that medium as it's being torn off. So I really had to think about the timing of it because it is actually a rather rapid process. But I hadn't really like internalized the image of it in my head scientifically. I just thought, oh, jellyfish galaxies, they're interesting in clusters. But there's a whole process. And so now my PI and I are working on actually a paper about this, looking at the very earliest stages of ram pressure stripping long before these galaxies turn into jellyfish galaxies. So just the first little bit of gas being pulled off. and trying to figure out when that happens.
Very cool. Awesome. Well, if you have a question for Dr. Alcorn, put it into the comments. But for the last half of the show, we're going to go over to our other performer, Molly Kewl, who came into the event at Science as a Drag wanting to express more scientific things that they found silly and weird and wanted to share with the audience. So Molly, and this is going to change us a little bit subject-wise, because we're talking about some of the largest things in the universe, but you are really sort of biology. You seem to love things Earth-focused. So why don't you tell us a little bit about some of the science and show us some things that you've got for us?
Well, so yeah, like I was saying earlier, something changed in me. I was a very shy kid, and something changed in me when I saw programs like The Magic School Bus and Bill Nye the Science Guy and Popular Mechanics for Kids. And then the Spice Girls. I'm a 90s kid, you know.
Same.
And then yeah, good. And then this turned into when I was in my mid-20s. I was trying to come up with some sort of way to express myself, to create something that was my own, to kind of take all of my interests and talents and put them all together. You know, one of my major ones was entomology, a bit of chemistry, geology, things like that. And then I found this other artist named Sophie, and she produces this very kinetic sounding music. It's very science, sci-fi sounding pop, experimental electronic music. And so out of that sound, this character was born. And so my first big debut performance, I did something that it was a chemical reaction called elephant toothpaste. And it's very like classic, like, you know, we do it in, you know, chemistry class. And what it is it's you mix yeast with peroxide and dish soap. And the reaction of the peroxide killing the yeast creates like the foam that we're used to when you put peroxide on a wound. And then the bubbling action makes the soap foam up. So it's very dramatic. And so my first performance, I had a necklace with all the ingredients, and then I mixed them, and then it foamed all over me. And actually, I wanted to do that at Science as a Drag, but they weren't so keen on messes, which is totally fair. Totally fair. I used to get in a lot of trouble at my first bar that I would frequent because I made a lot of messes. But yeah, I actually have that. I repurposed for my Science as a Drag performance. I repurposed my lab coat from that original performance, and I'm going to rhinestone her a little bit more one of these days. But if you look right here, this is my name, Kewl. And this is actually a font that I designed. And I did it during lockdown. And it was I wanted the font to look like, you know, planets and orbits and atoms and molecules and stuff like that. So I try to keep it either I'm a raver girl or I'm a scientist. So that's kind of my.
Now, Molly, you are you're performing a drag artist out there in Guelph. Is this a regular part of your acts, or is this like, how receptive do you find the audiences at drag events to sort of science, or do you kind of keep it separate?
No, so when I was in Toronto, I first started, and I did have this moment where I was trying to make myself a little bit more marketable. Like, this is something a lot of artists go through, right? We try to make it more palatable, more marketable, so that you can do more shows. But the reality is, art in itself is a lot of the time a bit selfish, a bit cathartic. So you are trying to express something, to work through something, to combine different aspects of yourself. Drag is a vehicle, a vessel for anything you want. And so when I first started, it was like I did that first number and people liked it, but then there was a bit of pressure to kind of be a little prettier and be a little simpler. And then I found the West End of Toronto drag, which was like more punk. And so that's when I started to go through a transformation. I started to allow my facial hair to grow in drag. I was known as like a mustache queen. That was sort of an ode to Einstein, that stereotype, you know. And then and then I eventually started to try to work in more props. And one of the ones that I have here too, I did at Science as a Drag, and I debuted back in 2018 or 2019ish. But I brought it all back and made it better. My presentation was on plasma.
Mm-hmm.
And so I had this, under that lab coat, I had this plasma balls, these small plasma, battery operated, and I had them attached to this bra. And it's like, you know, a little bit like a Madonna cone bra moment. So I revealed to the bra with the plasma balls. And if you want, you can put a link of some of the videos and stuff, because the footage we got at the show was amazing. The pictures we got at the show was amazing. I'm sure, Leo, you got some good videos and pictures too from what did you do it at Off-World Bar as well?
Yeah, we did it at Off-World. And
was this last year?
Yes, June 2023. And there is a short little video on the CBC webpage about it where I'm doing my actual strip.
That's amazing.
Don't worry, you don't see anything bad. You only see my stars and dark matter.
Well, you know what though? This is the thing, is like with queer art and it's really important to bring people, because there's so much intersectionality in the queer community, right? There's a lot of queer scientists. There's a lot of, you know, queer women, queer people of color, non-binary people. So what Science as a Drag did for me was it showed me that there were a lot of people out there like me who appreciated drag, who were queer, who also loved science and worked in science, or were aspiring to work in science. And I also know that a lot of the people there maybe hadn't seen drag yet, or a lot of people there they don't know too much about science. So the power in the intersection of art and anything else you want, science and art go so well together. We end up, you know, science and entertainment, science and art. That's sort of what, you know, what we're getting back to, like Bill Nye the Science Guy, Magic School Bus, things like that. And it's interesting earlier how you were talking about having to simplify things a little bit. When you go over it the first time, you have to simplify it in terms that people who aren't in studying your specific field will understand. And it's like, that's why shows like Magic School Bus and Bill Nye they appeal to adults as well, because when you are learning science, that's actually what my whole plasma presentation was about in Science as a Drag, it was about plasma has been left out for some reason. She's not taught. I said plasma was a she. It sounds like a female name.
Why not?
Plasma was not. Exactly. She wasn't taught in school unless you went to advance, you know, chemistry and things like that. But I remember when I first heard there was 4 states of matter, and I felt lied to. And I said, and that's what my comparison was in the presentation was, well, you know, like the queer community, there's this other state of being that is not as publicly talked about, not in the educational systems at the very least. And so that was sort of what my tongue-in-cheek presentation was about.
Yeah,
the usual drag, my favorite drag queen, she's a hot mess.
Exactly. And I definitely am.
Oh, this is amazing. You know, and what you said there about the performance and how places like even like where I work here at a planetarium, performers and people that are good at public speaking are generally drawn to places like this. And we generally do get, and right now we have a very wide, diverse people that come and work with us because they're drawn to wanting to talk about science, but maybe didn't pursue it, like Leo did. And where places like this and places like bars, where you can do different things and bring in people together that wouldn't necessarily be interacting together. Even, both of you here, I love sort of like seeing how each of you have this language that you're talking that is all about who we are as people living in this universe. You have just taken these different paths. And when we are talking about science, we are just talking about our understanding of it, and our understanding of it needs to come from such diverse voices to be fully understood. To end us off here, Leo, because you have gone through the traditional educational system, now sort of like where do you sit now? And obviously there must have been maybe some struggles going through a traditional system and getting your doctorate. Were you able to express yourself like this in the academic institutions, or did you have to kind of like keep things separate?
Well, part of it wasn't well, all right. So in the beginning, in undergrad, I found it was a little bit more traditional than I was hoping. So for example, it was very white male cis dominated. Sometimes they could be a little bit mean to the women who were involved, or anybody who was different. And that was a little bit disheartening, unfortunately. But I went to graduate school in Texas, and I found a really nice group, actually. I got really lucky in graduate school. I had very good mentors. I had very good postdoctoral mentors, and I sort of became more myself. I got involved in the Texas punk scene, which you wouldn't expect to be so good, but it really is. Oh my God, they have great punk there. And I sort of started to express myself more with how I dressed and how I talked. I started studying, well, not so much studying, but learning from a professor at Texas A&M, Tatiana Rukimova, who is actually all over YouTube doing science demonstrations about how to make it a little bit less traditional science communication, that is, and apply it to more diverse audiences and to make it fun. It doesn't have to be dry and academic, because not everybody's into that. It's nice to have a wide variety of methodologies and a lot of creativity. As Molly was saying, actually, art and science really do go together. Just really want to boost that as well, because it requires a lot of creativity to really get your ideas across, particularly when someone hasn't had the training or the jargon that you have. And then I got my doctorate, and I don't know, something clicked, and I decided I was okay with my femininity and decided to start dressing like in a more feminine way, because before that I only dressed in like band t-shirts and jeans and leather jackets and stuff. But now I kind of want to, I don't know. I feel the PhD, I feel like, gave me some confidence I didn't have before in myself and my body, and how I want to present myself.
Wonderful. Well, that's almost our time for the show. I could talk to you both for so much. This is so fascinating to me. Of course, like I said, I have been a fan from afar of this Science is a Drag annual show. One of these days, I'm hoping to get out there. Dr. Sam Amin, shout out to her, Science Sam on Instagram. One of my mentors from years ago, really brought me onto here. And of course, Robin Diamonds, who is a part of the Science is a Drag culture. Big fans of both of them. And they were both who I asked to bring you, both of you, onto this show. So thank you all for coming onto the show and for this conversation. Molly, you are performing out there. Do you have shows coming up that you'd like to plug?
The next one is I would check, but I'm using my phone for that. It's slowing down a little bit for Pride, after Pride. because our Pride here is June. So I'm guessing on the West Coast it's in July, right? Maybe I think it's in August in Quebec. But so yeah, it's going to slow down a little bit for Pride, but then usually October picks back up. We call it Gay Christmas for Halloween. And then so I'd say, you know, we'll point people to my socials, and then they can keep an eye out for more so for September, October is when I pick up. And I'll usually whip out the sci-fi stuff more close to October as well.
Yeah, wonderful. And we're gonna have a drag show. We had to postpone it, but we have a new date. So check on our website. We are having a drag show in our planetarium.
Nice.
New date now is August 24th. So it's not on our website yet. So make sure that you subscribe to our newsletter, so you're going to get all the information on that. Dr. Alcorn, are you going to perform again? You said that this is an experiment for you, but what's next on your plate?
I would love to perform again. I would need to apply. I've also done my dance actually for the Royal Astronomical Society of Canada when I visited really briefly.
Cool.
And yeah, because they called me to talk about jellyfish galaxies, and I figured, why not give them a little dance? Why not?
Right.
But yeah, I am at a juncture in my career now where I can go into a professorship, but I've determined that a research professorship isn't for me. But I've decided maybe to go into science communication or science support work, and then perform in my free time.
Awesome. Well,
Nice.
if you ever make it out here to the West Coast, we would love to host you in our planetarium to talk about all things space and drag. Thank you so much, Molly Kewl and Dr. Leah Alcorn. Thanks so much for joining us on this edition of Ask an Astronomer.
Thank you so much.
Thank you. Thank you so much.
And we will be back live in 2 weeks. I'll be on vacation this time, but your regular astronomer, Marley, is going to be with you hosting the Astronaut Project. So it's another Pride-themed show that is going to be with you, and that is going to be July the 25th. So make sure to tune in to that. Same time, 4 p.m. Pacific time. That's it for me, folks. Take care, everyone. Stay cool.